At 12:01 in the morning on November 8, 1942, in a shipyard at Richmond, California, the first welding arcs flashed across a steel keel plate. Sparks fell into the baywater below. Cranes swung prefabricated sections into place under floodlights. The yard was alive with hammering, with shouted orders, with the smell of hot metal and salt. No press release said so yet, but a clock had just started. 4 days, 15 hours, and 29 minutes later, that same hull, christened the Robert E. Peary, would slide into San Francisco Bay, fully assembled. 3 more days after that, she would be loaded with cargo and turned over to the Maritime Commission. 2 weeks after the keel was laid, she was at sea, carrying war material toward the Pacific. A few thousand miles away, in Berlin, when wire reports of this event eventually reached German intelligence offices, the figures were dismissed. Officers refused to believe them. They assumed the numbers were Allied propaganda, that no shipyard on Earth could turn raw steel into an ocean-going freighter in less than 5 days. They were wrong. And the reason they were wrong, the reason an entire nation of brilliant engineers refused to believe what their own intelligence services were telling them, is the story of one of the deepest and most decisive misunderstandings in modern history. This is the story of why Germany could not understand American interchangeable parts. It is a story that begins long before the first shot of World War II, in a sawmill on a small island in the Potomac River. It ends in the rubble of a flattened Reich, with German engineers boarding ships to Detroit to learn what they had spent 40 years refusing to see. To understand the gap, you must first understand what interchangeable parts actually are. The idea is older than the United States. In the 1770s, a French gunsmith named Honoré Blanc began producing musket locks, whose components could be exchanged from one weapon to another, without filing or fitting. In 1785, the American minister to France, Thomas Jefferson, watched Blanc demonstrate this principle. He wrote home to John Jay that Blanc had shown him 50 locks taken to pieces and arranged in compartments, that he had assembled several himself, and that the parts had fitted in a most perfect manner. Jefferson saw the future. France did not pursue it. Blanc died in obscurity, but the seed had crossed the Atlantic. The man most often credited with bringing interchangeable parts to America is Eli Whitney. The story is taught in every American schoolbook. In June 1798, with war against revolutionary France looming, Whitney signed a contract with the federal government for 10,000 muskets. 3 years later, in 1801, he stood before President-elect Jefferson and the Secretary of War and assembled musket locks from a basket of randomly selected parts. The legend was born. Whitney became, in the popular imagination, the father of the American factory. The legend is mostly false. When historians in the 20th century examined Whitney's surviving muskets, they found file marks, individual fitting numbers, and parts that did not interchange. The 1801 demonstration was almost certainly staged. Whitney's real talent was for promotion and finance, not precision manufacturing. The order took him roughly 10 years to fill. The actual achievement of true interchangeability belongs to 2 other men whose names most people have never heard. The first was Simeon North, a Connecticut farmer turned gunsmith, born in 1765. North began producing horse pistols for the federal government in 1799, working in a small shop in Berlin, Connecticut. He drove himself and his workmen toward greater and greater consistency. By 1813, his federal pistol contract included an explicit clause demanding that the component parts of pistols correspond so exactly that any limb or part of one pistol may be fitted to any other pistol of the 20,000. This was the first time such language appeared in an American government contract. North spent the next 30 years living up to it. The second man, and the one who finally made the dream real, was John Hancock Hall. Hall was a Maine carpenter and gunsmith who had patented a breech-loading rifle in 1811. In 1816, he proposed something extraordinary to the United States Army Ordnance Department. He proposed to build rifles in which the component parts of guns shall be made so exactly alike that any part of one gun may be used in place of the same part of another gun of the same model. 3 years later, the Army accepted. Hall was given a contract and a workshop at Harper's Ferry, Virginia, on a small river island that came to be called Hall's Island, near Virginius Island, where he set up production in an old armory sawmill above the Potomac River. For 7 years, Hall worked. He designed his own machine tools. He built jigs and fixtures that held the parts in identical positions for every cut. He invented gauges that allowed his workers to test each part against a master pattern. He insisted, against every shop floor instinct of the period, that no part be filed or fitted by hand. The work was unglamorous. It was making the same cut on the same piece of steel 1,000 times in a row, and then measuring it against a steel template, and then doing it again. In 1826, an ordnance board sent by Congress arrived at Harper's Ferry to inspect the work. Their report was almost reverent. They wrote that arms had never been made so exactly similar to each other by any other process, and that the machines they had examined effected this with a certainty and precision they should not have believed till they witnessed their operation. By the mid-1830s, Hall and Simeon North, working 200 miles apart in different states, were producing rifle parts that could be freely exchanged between their two factories. A part made in Connecticut would fit a weapon made in Virginia. The American system of manufacturing had been born on a small island above a river, in the careful, patient hands of men whose names almost no one would remember. What happened next would echo for 100 years. In 1851, Britain hosted the Great Exhibition at the Crystal Palace in London. The American section was small, half empty, and at first was mocked in the British press. Then, on November 25, a Connecticut gunmaker named Samuel Colt addressed the Institution of Civil Engineers and demonstrated the assembly of revolvers from interchangeable machine-made parts. The British engineering establishment was stunned. The Royal Navy began ordering Colt revolvers within weeks. The shock was so deep that the British Parliament, in 1853, dispatched 2 delegations to America. One was the Committee on the Machinery of the United States, which included James Nasmyth, the inventor of the steam hammer. The other was led by Joseph Whitworth, the foremost machine tool maker in Britain. Their reports, submitted in 1854 and 1855, conceded American superiority in firearms manufacture without qualification. They returned to England not just with words, but with 150 American machine tools, purchased from the Robbins and Lawrence Works in Windsor, Vermont, and installed at the Royal Small Arms Factory at Enfield. The phrase American system of manufactures entered the European technical vocabulary at that moment. It would haunt European industry for nearly a century. Germany took notice. Germany did not follow. To understand why, you must understand the German manufacturing tradition as it stood in the late 19th and early 20th century. It was rooted in the medieval guild, and the heart of it was a man called the Meister. The path to becoming a Meister was long and exact. A boy began at 14 as a lehrling, an apprentice, bound by formal contract for 3 years to a master who taught him a trade. After his apprenticeship, he became a gazelle, a journeyman, and traditionally spent his Wanderjahre, his wandering years, travelling from town to town to learn from other masters. Only after years of practice could he take the Meisterprüfung, the master's examination, and produce a Meisterstück, a masterpiece, that proved his skill. Only then was he granted the Meisterbrief, the master's letter, which gave him the right to open a shop and to train apprentices of his own. This was not nostalgia, it was law. The German state recognized the Meisterbrief as a formal qualification, and the system continues today. Below the Meister stood the Facharbeiter, the certified skilled worker, the backbone of every German factory. The reputation that the world came to call Made in Germany was built on these men. They produced the Mauser rifle. They produced the lenses of Carl Zeiss and the optics of Leitz. They produced the engines of Daimler and the artillery of Krupp. They produced things that worked beautifully and lasted decades. What they did not produce, and what their entire training discouraged them from producing, was the kind of soulless, identical, machine-made part that an American factory could turn out by the million. In the German shop, quality lived in the hands of the master. In the American factory, quality lived in the gauge, the jig, and the specification. To a German Facharbeiter of 1930, the American method looked crude. It looked like a betrayal of the craft. It looked, frankly, beneath him. Henry Ford had no such scruples. In 1913, at his Highland Park plant in Michigan, Ford completed the first moving assembly line in industrial history. A Model T chassis that had once taken 12 hours to assemble was now finished in 93 minutes. By 1927, Ford had completed the River Rouge complex, the largest factory in the world, where iron ore arrived at one end and finished automobiles drove out the other. The principle was the principle that John Hall had proven in 1826. Make the parts identical, move the work past the worker, replace skill with system. The Germans came to look, so did the Italians, the Japanese, and the Soviets. From the 1920s onward, delegations from every industrial nation passed through River Rouge. Adolf Hitler kept a portrait of Henry Ford on his office wall in Munich. In 1938, Hitler personally laid the cornerstone for a new factory at Wolfsburg, modelled on Ford methods, that was supposed to produce a people's car, the Volkswagen, for the German worker. The cornerstone was laid. The car was barely built. Before mass production could begin in any serious way, the war intervened, and the Wolfsburg plant was converted to military work. This was the German pattern. They studied American methods. They imported American machine tools. They sometimes hired American advisors, but they could not bring themselves to fully accept the underlying philosophy that the work of the trained master could be replaced by the work of a system. The Reich kept the Ford-style assembly hall and kept the Meister-centered shop floor at the same time. The result was a hybrid that produced a small number of exquisite weapons at enormous cost, when the war that was coming would demand a flood of adequate weapons at low cost. The man who would eventually be made responsible for closing that gap was an architect. Albert Speer, born in 1905, had been Hitler's personal architect since 1934. He had no manufacturing background whatever. On February 8, 1942, after the previous armaments minister Fritz Todt died in a plane crash, Hitler appointed Speer as Reich Minister of Armaments and Munitions. Speer was 36 years old. He was given an industrial economy that was already, in 1942, falling behind. He spent the next 3 years trying to catch up. He never did. It is worth pausing here to understand the world Speer had inherited. In May 1940, before America had even entered the war, President Franklin Roosevelt stood before Congress and announced a goal. The United States, he said, would build 50,000 military aircraft a year. He would later raise that number to 60,000 and then higher. In 1939, the entire American aircraft industry had produced fewer than 3,000 military planes. The figure Roosevelt was demanding was, on its face, a fantasy. In Berlin, the figure was treated as exactly that. German intelligence, working from outdated assumptions about American capacity, badly underestimated what Roosevelt's program could achieve. Hitler himself, in conferences with his generals during 1940, dismissed American rearmament as something that would not reach its peak before 1945. He was telling his commanders, in effect, not to worry about the United States. By the time the Americans were ready, the war would be over. He was wrong by orders of magnitude. By 1944, the United States was producing more than 95,000 military aircraft in a single year. The cumulative wartime total would approach 300,000. American intelligence estimates of German production, by contrast, were if anything too high. The two sides were not just on different industrial trajectories, they were on different planets. On December 11, 1941, 4 days after the Japanese attack on Pearl Harbor, Adolf Hitler stood before the Reichstag and declared war on the United States. He did not have to. The Tripartite Pact did not require it. He chose to. In private, in the days surrounding Pearl Harbor, Hitler told his entourage that they could not lose the war at all, that they now had an ally that had never been conquered in 3,000 years. He meant Japan. Within hours of his declaration, the full industrial weight of the United States was committed against him. The man who organized that weight was named William Knudsen. He had been born in Denmark in 1879 and had immigrated to America with $30 in his pocket. He had risen through Ford to become president of General Motors, the largest corporation in the world. On May 28, 1940, Roosevelt asked him to come to Washington. Knudsen resigned his $300,000 salary, took a federal job for $1 a year, and set about converting American civilian industry to war production. In January 1942, the United States Army commissioned Knudsen directly as a lieutenant general. He remains the only civilian in American history to be commissioned at 3-star rank without prior military service. Knudsen later wrote, with the bluntness of a man who had spent 40 years on factory floors, that they had won because they smothered the enemy in an avalanche of production, the like of which he had never seen, nor dreamed possible. The avalanche took specific, almost unbelievable forms. The first was a building. In January 1941, Ford Executive Vice President Charles Sorensen traveled to San Diego to inspect the production line of Consolidated Aircraft, which was building the B-24 Liberator heavy bomber. What he saw appalled him. Aircraft were being assembled outdoors, in the California sun, on individually built jigs that warped as the temperature changed. Sorensen later wrote that it was obvious to him that if the wing sections had uniform measurements, the way Ford made parts for automobiles, they would not fit properly under outdoor assembly conditions. That night, in his hotel room at the Coronado, he sketched on hotel notepaper a single building, 1 mile long and a quarter-mile wide, that would assemble bombers the way Detroit assembled cars. Edsel Ford initialed the sketch the next morning. The factory was called Willow Run. It was built on Ford-owned land in Washtenaw County, Michigan, designed by the industrial architect Albert Kahn. Ground was broken in the spring of 1941. The plant was dedicated on June 16, 1942. The first complete B-24 rolled out in October 1942. The main building covered approximately 3.5 million square feet under one roof. To avoid the building crossing into a second county and being subject to 2 tax jurisdictions, the design included a 90-degree turn in the assembly line known as the tax turn. In April 1944, at the peak of its operation, Willow Run produced 453 B-24 Liberators in 468 hours. That worked out to one finished 4-engine bomber rolling off the line every 63 minutes, 2 9-hour shifts a day, 6 days a week. Between April 24 and April 26, 1944, 100 completed bombers were flown out of the airfield. By the time production ended in May 1945, Willow Run had built 6,792 complete B-24s and supplied another 1,893 knockdown kits to other plants. About half of all the 18,482 B-24s built during the war came from this single building. The workforce inside it, at peak, exceeded 42,000 people. They were farm boys from Ohio, sharecroppers' daughters from Alabama, retired school teachers, men who had failed the draft for medical reasons, and women who had never operated a drill press in their lives. Many of them lived in tar paper trailer parks thrown up around the plant. They worked in noise so loud that hearing loss was assumed and accepted. They were not, by any traditional German measurement, skilled workers. They did not need to be. The system was the skill. Sorensen had once promised, in front of skeptical aircraft executives, 1 bomber an hour. Established aircraft makers had laughed at him. By 1944, they were not laughing. The second form of the avalanche came from the sea. The Liberty ship was a simple, welded freighter, adapted from a British 19th-century tramp steamer design, intended to carry cargo across the Atlantic faster than the German U-boat fleet could sink it. The Anglo-American emergency program would eventually build 2,710 Liberty ships, the largest single class of ocean-going vessels ever constructed. The man who organized the bulk of the program was Henry Kaiser, a builder of dams and roads who had never built a ship in his life. Kaiser's innovation was prefabrication on a massive scale. Sections weighing up to 250 tons were built in factories all across the United States, sometimes 1,000 miles inland, and then shipped by rail to 7 Kaiser shipyards on the coasts. There they were welded together, not riveted, in a process that cut construction time by a factor of 10. At the start of the program, a Liberty ship took roughly 355 days and 1.4 million man-hours to build. By the middle of 1943, the average had fallen to about 42 days. At Kaiser's yards, it could be done in 17. Then, in November 1942, Kaiser decided to make a point. At 12:01 in the morning on November 8, the Permanente Metals Corporation No. 2 yard at Richmond, California, laid the keel of Liberty, hull No. 47, christened the Robert E. Peary. 250,000 prefabricated parts, weighing about 14 million pounds, were assembled in 4 days, 15 hours, and 29 minutes. She was launched on November 12 and delivered to the Maritime Commission on November 15. Total time from keel laying to delivery was 7 days, 14 hours, and 32 minutes. Kaiser called the Peary an incentive ship. Critics called it a stunt ship. Both were right. The average build time at Permanente was about 50 days, and the Peary was a one-off, a deliberate piece of theatre intended to humiliate slower yards and to terrify Berlin and Tokyo. But the Peary was no propaganda hull. On November 22, 10 days after launch, she sailed for the Pacific with a full cargo. She served through the entire war. She was off Omaha Beach the day after D-Day, carrying men and equipment from Cardiff to the Normandy beachhead. A single Liberty ship of her class, built in 17 days at average speed and 4 days at theatrical speed, could carry roughly 2,840 jeeps or 440 light tanks, or enough rations to feed 16 million soldiers. The aggregate American war production between 1940 and 1945, when you stand back and look at it, becomes almost mathematically dreamlike. Roughly 297,000 military aircraft, approximately 86,000 tanks and self-propelled guns, about 2.4 million military trucks, around 193,000 artillery pieces, roughly 41 billion rounds of small arms ammunition, 141 aircraft carriers, including escort carriers, 203 submarines, 349 destroyers and destroyer escorts, 2,710 Liberty ships. American tank production alone went from 331 units in 1940 to 29,497 in 1943. Detroit produced about 30% of all American war material. In 1941, American manufacturers built over 3 million civilian cars. After Pearl Harbor, only 139 more would be made before the end of 1945. Set against this, set the German numbers. The Tiger, one heavy tank, which the Wehrmacht considered the finest armoured vehicle of the war, was produced from August 1942 to August 1944. Total production was approximately 1,350 units. The Tiger II, the King Tiger, an even heavier successor, was produced from late 1943 through April 1945. Total production was 492 units. The Panther, the medium tank designed to counter the Soviet T-34, reached approximately 6,000 units across the entire war. The American M4 Sherman tank, by contrast, was produced in approximately 49,324 units. The Soviet T-34 was produced in over 57,000 units during the war years. American production of one tank model exceeded the entire German tank and assault gun production of the war. The numbers are not close. They are not in the same arithmetic. The reason the numbers are not close lies in the Tiger itself. According to the Tiger Fable, the official Tiger crew manual issued by the Wehrmacht, each Tiger I tank required approximately 300,000 man-hours and 800,000 Reichsmarks to build. The manual dramatized this as 1 week of hard work for 6,000 people. The figure is approximate, and modern historians like Christopher Wilbeck and Thomas Jentz place the real number somewhere between 200,000 and 300,000 hours, but the order of magnitude is correct. By comparison, an American M4 Sherman, in early production, required roughly 48,000 man-hours, falling well below that as Detroit's lines learned their work. A Soviet T-34 in 1943 could be produced in about 3,700 man-hours at the best Soviet plants. In labor alone, building one Tiger cost about as much as building 6 Shermans or 40 T-34s. The Tiger had thicker armor, a longer-ranged main gun, and a more sophisticated fire control system than anything the Allies fielded until late 1944. In a one-on-one duel on open ground, a Tiger could destroy multiple Shermans before being hit itself. Tank crews on both sides knew this. The problem for the Reich was that wars are not fought as duels. The Sherman crews lost in the morning could be replaced by lunchtime, and so could their tanks. The Tiger crews lost in the morning could not. The Tiger was a magnificent weapon. The Sherman was a magnificent system, and the system always wins. The same pattern held in the air. The Messerschmitt B F-109, the principal German fighter, was produced in approximately 34,000 units across the war, making it the most produced fighter aircraft in history. But it was produced in such a chaos of variants that maintenance became a nightmare. The principal lettered series ran from B and C through D, E, F, G, and the late war K, with a separate carrier variant T. Within the G series alone, there were Umrust Bausatze, factory conversion kits, designated U1 through U4, and Rustsatze, field modification kits, designated R1 through R6. Each variant had subtly different fittings, slightly different parts, slightly different requirements. A German mechanic in the field, presented with a damaged 109, had to first determine which variant he was working on, then locate the correct manual, then find the correct parts, which were not necessarily compatible across variants. An American mechanic working on a P-51 Mustang opened a parts crate and pulled out the part. It fitted, every time. This is what interchangeability meant in practice, on a battlefield, when a fighter had to be back in the air by morning. The Wehrmacht's vehicle catastrophe is perhaps the clearest single illustration of the German production problem. In late 1938, the German army was using more than 100 different truck and passenger car designs, drawn from civilian production, foreign captures, and a partly failed standardization program. In November of that year, Colonel Adolf von Schell was appointed General Plenipotentiary for motor transport. His mandate was to bring order to the chaos. The Schell Plan, presented in March 1939 and effective from January 1, 1940, sought to reduce 114 truck types to 19 and 52 passenger car types to 30. It did not work. The press of war, the capture of foreign factories, and Hitler's habit of issuing direct Führer orders that bypassed Speer's ministry constantly reintroduced new variants. By 1944, despite Speer's efforts at rationalization, the Wehrmacht was still using more than 150 distinct truck types when foreign captured vehicles, civilian conversions, and motorcycle variants were counted. A spare gearbox shipped to a unit in Russia might or might not fit any given truck on the lot. Mechanics improvised, vehicles broke down, supply officers tore their hair. The American Army solved this problem by doing exactly what John Hall had done at Harper's Ferry in 1826. They standardized. The Willys MB Jeep, with the Ford GPW produced to identical specifications, totaled approximately 640,000 units. The GMCCCKW 2.5-ton truck, the famous Deuce and a Half, totaled roughly 562,000 units. The Studebaker US-6, a 2.5-ton six-wheel drive truck, totaled approximately 197,000 units. The Dodge WC series, in half-ton and three-quarter-ton variants, totaled more than 380,000 units. The United States shipped approximately 400,000 vehicles to the Soviet Union under Lend-Lease alone, more than the entire wartime Soviet truck production. The Studebaker became the standard mount for the Soviet Katyusha rocket launcher. Russian soldiers called the truck Studa with affection. Soviet artilleryman Ilya Mariasin would later write that the Studebaker deserved a monument like the ones everywhere given to the famous T-34 tank. By the closing months of the war, official Soviet appreciation of the truck was being communicated through formal channels back to its manufacturers in South Bend, Indiana, where Studebaker received recognition for its contribution to the Eastern Front. This brings us to the most famous toast of the war. At the Tehran Conference on November 30, 1943, Joseph Stalin rose at a dinner table in the Soviet embassy and proposed a toast. The State Department interpreter Charles Bolan took down the words. Stalin spoke about machines. He said the United States was producing 8,000 to 10,000 airplanes a month. He said the Soviet Union, at maximum effort, could turn out 3,000. He called the United States a country of machines. He said that without those machines, supplied through Lend-Lease, the Allies would lose the war. This was not propaganda for foreign consumption. Stalin said it in private, to Roosevelt and Churchill. Nikita Khrushchev would later confirm the same view in his memoirs. Khrushchev wrote that if the United States had not helped them, they would not have won the war. He wrote that one-on-one against Hitler's Germany, the Soviet Union would not have withstood its onslaught and would have lost the war. The Soviet leadership knew. They simply could not say so publicly during the Cold War. The German leadership knew too. The evidence appears again and again in their letters, their conferences, and their interrogations after the war. Field Marshal Erwin Rommel, fighting in North Africa, wrote in November 1942 from El Alamein that anyone who has to fight, even with the most modern weapons, against an enemy in complete command of the air, fights like a savage against modern European troops, under the same handicaps and with the same chances of success. Rommel later wrote of the Americans in Tunisia that they had paid a stiff price for their experience, but that it had brought rich dividends, and that even at that early stage their generals had shown themselves very advanced in the tactical handling of their forces. Field Marshal Gunther von Kluge, who took command in Normandy after Rommel was wounded, wrote to Hitler in July 1944 that in the face of total enemy air superiority, they could adopt no tactics to compensate for the annihilating power of air except to retire from the battlefield. A month later, Kluge wrote a final letter to Hitler and shot himself. General Heinz Guderian, the architect of the German tank arm, wrote in his memoirs that the war had become a Materialschlacht, a battle of material, and that this was a kind of war Germany could only have won by avoiding, not by fighting. General Friedrich von Mellenthin, encountering the Soviet T-34 for the first time in October 1941, wrote 4 words that summarize the entire German experience of the war. "We had nothing comparable." Speer himself, the Reich Minister of Armaments, raised German output through ruthless rationalization and through the savage exploitation of forced and slave labor under Fritz Sockel. Between February 1942 and July 1944, the Speer index of armaments production more than tripled. It was not enough. It was never going to be enough. Speer admitted this in his interrogations after the war. When American economists Paul Nitze and John Kenneth Galbraith questioned him at Flensburg in May 1945, Speer said, in substance, that the gap was structural, and that even with full rationalization, Germany could not have closed it within the time the war allowed. Speer wrote in his memoirs, Inside the Third Reich, that Hitler had repeatedly dismissed American manufacturing as an artificial construct, dependent on what Hitler called Jewish finance, and what he called inferior labor, and incapable of producing weapons of true quality. Speer recorded Hitler saying in 1942, when shown a German engineer's contemptuous report on an American factory, that the Americans built cheap things, while the Reich would build weapons of eternal value. Speer wrote that this was, perhaps, the most damaging illusion of the entire war. He also wrote, in a passage that has haunted readers ever since, that he grew dizzy when he recalled that the number of manufactured tanks had seemed to him more important than the vanished victims of racism. Speer was tried at Nuremberg. He was convicted of crimes against humanity for his use of slave labor. He was sentenced on October 1, 1946, to 20 years in prison. He served the full sentence at Spandau and was released on October 1, 1966. His memoir would come out 3 years after that. Modern historians, especially Adam Tooze in his book The Wages of Destruction, have shown that Speer's so-called armaments miracle was partly real and partly a self-serving statistical illusion. Speer chose January and February of 1942, months of unusually low output, as his statistical baseline. Much of what looked like a Speer miracle was simply the maturation of investments his predecessor Fritz Todt had made before 1942, ordinary learning curves at the workbench, and the brutal expansion of slave labor. The decisive impact of the production gap appeared on every front. In the Battle of the Atlantic, German U-boats sank approximately 1,664 Allied merchant ships in 1942 alone, totaling roughly 7.8 million tons, or about twice what the British merchant marine could replace. In the spring of 1942, German submarines were sinking ships off the American East Coast within sight of beach hotels in Florida and the Carolinas, and the convoys crossing to Britain were taking losses that, in any sane calculation, should have starved Britain into submission. By the autumn of 1943, however, every Allied ship sunk since the start of the war had been replaced by American Liberty ship production. In May 1943, the Allies sank 41 U-boats in a single month, a month the Germans called Black May. Admiral Karl Donitz, watching his force collapse, withdrew the Wolfpacks from the North Atlantic. The submarines had not been outfought, they had been outbuilt. Every sinking that had once seemed catastrophic was now arithmetically routine. The shipyards in Richmond and Mobile and Portland and South Portland and Baltimore poured out replacements faster than Donitz's torpedoes could send them down. On the Eastern Front, the Soviet Union evacuated more than 1,500 large industrial plants and millions of workers and family members east of the Ural Mountains during 1941 and 1942, an industrial migration without parallel in human history. During the gap year of 1942, when Soviet domestic production was still rebuilding in Siberia, American Lend-Lease filled the holes. American aluminum, copper, aviation fuel, locomotives, rail cars, and trucks kept the Red Army moving. Operation Bagration, the Soviet offensive of June 1944 that destroyed German Army Group Center, was carried forward primarily on the wheels of American Studebaker trucks. In the West, the build-up for D-Day moved 50,000 vehicles ashore in the weeks after June 6, 1944. The Red Ball Express, the truck convoy system that supplied the Allied armies racing across France, ran on identical GMC and Studebaker trucks, rolling identical parts off identical assembly lines in Detroit and South Bend. By the time of the German Ardennes offensive in December 1944, the last great German attack of the war, the Wehrmacht had assembled approximately 410,000 men, 1,400 tanks and assault guns, and 2,600 artillery pieces. Within 10 days, the offensive was halted, not because the Americans were better soldiers, although they fought hard, but because the Germans simply ran out of fuel and replacement vehicles, and the Americans never did. When the cumulative totals are set side by side, the war on the Western and Eastern fronts becomes, in retrospect, a straightforward equation. Cumulative Allied tank production, counting American, Soviet, British, and Canadian, came to roughly 200,000 vehicles. Cumulative German tank and assault gun production came to approximately 50,000. Cumulative Allied military aircraft production came to approximately 633,000. Cumulative German aircraft production came to approximately 120,000. The ratios were 5-to-1 in tanks, more than 5-to-1 in aircraft, and roughly 10-to-1 in trucks. No army on earth, no matter how brilliantly led, could overcome that arithmetic. After the war, the wreckage-strewn beaches of Normandy stood as their own argument. Sherman tanks burned. Liberty ships, holed by mines, sat on the sand. Crashed transport aircraft littered the bluffs. Each piece could be replaced by another identical piece, rolling off another identical line. The Reich could not replace its losses on anything like that scale. It had built weapons of eternal value in a war that consumed weapons by the trainload. The Reich surrendered on May 8, 1945. Germany lay in ruins. American occupation policy under Directive JCS 1067 initially aimed at a degree of industrial dismantling, but by 1947, with the Cold War beginning, the policy reversed. On June 5, 1947, Secretary of State George C. Marshall announced what would become the European Recovery Program in a speech at Harvard. Between 1948 and 1952, approximately $13.3 billion in American aid flowed to 16 Western European countries. The Federal Republic of Germany was among the largest recipients. What followed was, in its quiet way, the final reversal of 40 years of German manufacturing pride. Even before the war, Volkswagen's leadership had understood the gap. In 1937, the directors of the new German People's Car Project traveled to Detroit to study Ford's River Rouge plant and to recruit German-American engineers, including Fritz Kuntzer, the former power plant manager at River Rouge. They brought back machinery, blueprints, and methods. But the war, and the Reich's wider refusal to fully embrace mass production, prevented the methods from taking root. The Wolfsburg plant, founded in 1938 in conscious imitation of Ford, had built fewer than 1,000 civilian Beetles before being converted to military work, and survived the war as a damaged shell. Under British Major Ivan Hurst, civilian production at Wolfsburg resumed in 1946. Over the following years, the methods that had been imported from Detroit before the war were finally allowed to do what they had been designed to do. Conveyor lines moved cars through identical workstations. Parts were standardized to gauges. By 1954, Volkswagen had completed what its corporate historians describe as the changeover to large-scale standard production. By 1962, Volkswagen alone produced more passenger cars per year than the entire pre-war German automotive industry had managed in any single year. The Beetle that became the symbol of the German economic miracle was built using the methods of Henry Ford and, at one further remove, of John Hall. The same pattern repeated across German industry. Daimler-Benz, BMW, Krupp, Siemens, MAN, all rebuilt, all eventually competitive with American manufacturers, all having first quietly accepted the principle that the Reich's wartime leaders had refused to accept. Quality could be designed into the product through specifications and gauges, rather than depending entirely on the hands of a master. The two could coexist. They had to. The Germans had not been wrong about craftsmanship. Their tradition had produced some of the finest weapons and machines of the 20th century. The Tiger tank was a masterpiece. The Mauser action was a masterpiece. The Zeiss optic was a masterpiece. The Reich's mistake was in believing that masterpieces won wars. They do not. Wars are won by what can be built, replaced, fueled, repaired, shipped, and put back into the line by morning. They are won by the boring, unglamorous, almost contemptible miracle of two parts that fit each other regardless of which factory they came from. That miracle had been worked out, over 30 years, by John Hall in a sawmill in Virginia and Simeon North in a workshop in Connecticut. Men whose names appear on no monuments of any size, and in no school textbooks worth speaking of. It had been carried forward by an ordnance board in 1826 who could not believe what they were seeing, by Samuel Colt in front of British engineers in 1851, by Henry Ford at Highland Park in 1913, by Charles Sorensen at a hotel desk in San Diego in 1941, by Henry Kaiser at a Richmond shipyard in 1942, by William Knudsen working for $1 a year in a borrowed office in Washington. None of these men were artists. They were system builders. And the system they built, taken together, defeated an enemy whose individual products were often technically superior to anything America put into the field. There is a temptation, looking back, to describe the German failure as a failure of imagination. That is not quite right. German engineers had plenty of imagination. They imagined the jet engine, the assault rifle, the ballistic missile, the snorkeling submarine. The failure was something stranger and more cultural. It was the inability to imagine that a nation of car makers and immigrants and farm boys, working in factories where no one had taken a Meisterprüfung, where the men on the line had often never used a lathe before 1941, where the women, the African-American workers, the recent arrivals from Appalachia and the Mexican border, were doing work the Reich would have considered, beneath any properly trained artisan, could in the end outproduce a Reich whose industrial culture was older, prouder, and more refined than anything the New World possessed. The Germans could not understand it because to understand it would have meant accepting that the master craftsman was no longer the irreducible unit of quality. It would have meant accepting that the gauge had replaced the hand. It would have meant, finally, accepting that there is a kind of greatness that lies not in the perfect single thing, but in the unremarkable thousandth thing, identical to the 999 that came before it, ready to be carried in a Liberty ship across an ocean and dropped into the muddy gearbox of a truck that would carry food to a soldier still alive that morning. The Reich did not lose the war on the battlefield. It lost the war at Harper's Ferry in 1826, when an ordnance board reported on machines whose certainty and precision they had not believed until they witnessed their operation. And Germany, watching from across the Atlantic, decided not to pay attention.